Again, my name is Eugene Kawamoto. I'm presenting today about why AWS is the best place to build your MySQL workloads. In particular, we'll be focusing around our managed database services today. So we'll be covering various topics around MySQL, in particular focusing on Amazon Aura MySQL as well as RDS MySQL, our managed database services. We'll be diving deep into our architecture and also talking about our innovation and customer case studies today. So if you're here, you're probably pretty familiar with MySQL and its ecosystem. With that, let me set a little bit of context. So MySQL is the first database, open source database that was built in 1995. So it has a long history of almost 3 decades of development. And if you're old enough, you probably remember that this was the early days of the internet. Many applications were built on the LAMP stack using MySQL, and MySQL was really one of the primary databases to support the internet. But even today, MySQL is one of the most popular open source databases that is widely used. At Amazon, we also have a long history of managing various different databases. And back in the days, a lot of our developers were facing common challenges like setting up your infrastructure, configuring your database, as well as setting up read replicas for high availability. However, these are tasks what we call undifferentiated heavy lifting, and we wanted our developers to focus on innovation and keeping our customers happy instead of just keeping the lights on. So that's why we built what we call managed database services. So we launched our first managed database service, RDS MySQL, back in 2009. So this is 14 years ago. As we saw more and more customers building cloud-native services, we asked ourselves, how can we build a database that is truly cloud-native? And that's how we introduced Aura MySQL in 2015. We also kept innovating on various different MySQL-related databases, and we introduced Amazon RDS for MariaDB also in 2015. And after 8 years of introducing Amazon Aura, Aura continues to be the fastest growing service at AWS. So before we dive deep, let's cover a little bit of the overview around both RDS for MySQL as well as Aura for MySQL. So RDS for MySQL is a fully managed database that helps you set up, operate, and scale MySQL databases in just a few clicks. So it's really focused on taking out the muck of managing a database and just keeping the lights on. And we all know that database availability is extremely important. So MySQL helps you set up a high availability configuration in just a few clicks. In addition to that, it also helps you simplify your migration path for lift and shift and move to managed type of scenarios. So these are migrations that you might be working on to move from on-prem or EC2 MySQL type of workloads. And we support over 100 different instance types today to make it easier for you to pick the right price performance to move your MySQL workloads onto RDS MySQL. And we also have Database Migration Service, or DMS, as a common tool that many customers use to help this migration. Amazon Aura for MySQL is really our cloud-native signature managed database. So we combine the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases at 1/10 the cost of traditional commercial databases. So Aura is fully compatible with MySQL, so you don't have to make any changes to your existing applications. And the secret sauce is really around the storage architecture, which we'll cover in our architecture slides further. So let's talk about the under-the-hood architecture that powers both RDS and Aura MySQL. Let's also cover some of the common pain points that you might face with MySQL problems with MySQL and how our managed databases are solving some of these problems. So for RDS for MySQL, you have multiple different deployment options. And the most basic option is a single AZ deployment. This is where you have a single database instance that has EBS volumes attached to it. So this may look familiar as you build a self-managed MySQL environment on your own. You might use EC2 and EBS to set up this type of configuration. However, the largest difference is that the RDS control plane takes care of provisioning the infrastructure on behalf of you. In addition to that, if anything happens to your primary instance, behind the scenes, RDS control plane will restart or even replace your instance to make sure that you can keep up and running. However, if this does not succeed, you still have to manually recover your database. And depending on the situation, this may take hours or even days to recover. So while single AZ is great for dev and test and low SLA type of workloads, we don't recommend it for production systems. So to build a highly available architecture for production workloads, we have multi-AZ deployments. So in this case, the RDS control plane will deploy a secondary standby instance. Doing this on your own, you also have a couple options, but it's not that simple. For example, you can use binlog-based replication. However, binlog, as we all know, is asynchronous replication. Setting up your own storage-based replication, such as DRDB, can also be complex. You also have to implement things like heartbeat monitoring to make sure that your primary instance is up and running and determine when to fail over. This can also be tricky if you see a network glitch, and you don't want to fail over each time you see a network glitch as well. So multi-AZ solves a lot of these problems and makes it a single click. So we enable physical synchronous replication from the primary EBS volume to the secondary EBS volumes. So transactions are committed once these writes are completed in the two EBS volumes. Failovers typically happen in 1 to 2 minutes, and we'll be doing the crash recovery and DNS propagation behind the scenes. So you don't have to worry about redirecting your application to the secondary instance after failover. Also, note that backups of transaction logs and snapshots will occur off of the secondary instance, so the primary EBS volume will not be affected during production workloads. So multi-AZ applies to a lot of different use cases, and we have a ton of customers that are using it today, but there are some limitations. First of all, the secondary instance is a standby. In other words, it doesn't take any queries or read queries. Second, there is some write latency compared to a single AZ architecture. This is because we have to do the commits and do the writes back to both of the EBS volumes sequentially. And third, it can take up to 2 minutes to fail over. This is also due to the crash recovery that is necessary. So multi-AZ with 2 readable standbys solves many of these problems. So we utilize binlog-based semi-synchronous replication combined with local NVMe SSDs to store the bin logs. So the first benefit around this is you can take reads from your secondary instance. In other words, the secondary instance could act as read replicas. Second, because we use the NVMe SSD disks, data does not have to be committed back to the EBS volumes. The EBS volumes are network attached, but the SSDs are local SSD disks, meaning that you get a lot more faster commit latency. So you really get the best of both worlds, the ability to read from secondary instances and getting low commit latencies. And finally, the recovery time goes down to typically 25 to 75 seconds. And because of the secondary instance is already up and available, and this is unlike multi-AZ with a single standby, which has to do the crash recovery after failover. Okay, so let's switch topics and talk about Aurora MySQL. So one of the main architecture differentiators about Aurora is how we separate compute and storage. So when you provision an instance, you have a read-write node. And at the storage layer, we use a fleet of shared storage volumes as a regional service. So by default, you get storage that is deployed across 3 availability zones. When you write 6 copies of log records that are written into shared storage volumes in 10 gig segments. And in order to complete a transaction, 4 out of the 6 nodes need to be written into the storage nodes, which also provides high durability. Reads are done from 1 copy, which is typically from your local storage to get low latency. And we keep the sequencing number of the storage nodes to know which nodes have the latest data, so you don't have to read from multiple copies. Storage capacity also automatically grows as your data grows as well. And you can have up to 128 terabytes of data where you only pay for 1 copy. In case of storage node failures, we also have automatic healing capabilities that will also recover your data, so there's no manual intervention required. So for reader instances, you can have up to 15 read replicas. These can also serve as failover nodes in case the primary node fails. And a big benefit about the storage fleet is when you create a new read replica, you don't have to duplicate the storage. So this is because we leverage the same shared storage fleet. And you also get low replication lag, typically under double-digit milliseconds. So this is a big difference from Community MySQL, where replication lag can be variable depending on your data size, and this is due to the single-threaded nature and replay of bin logs. Buffer cache of the read-only nodes are also asynchronously replicated, which keeps the memory up to date and typically takes only a few milliseconds. And you can also mix and match different instance type in a single cluster, meaning that you can have a provision instance and also combine it with serverless options depending on your use case. So let's cover failovers. So if you have a failover, we fail over to the read-only nodes. Typically, this takes around 30 seconds due to the DNS propagation. And we also have a JDBC driver that caches the topology of the cluster, so you don't have to rely on DNS, so you can have even faster failover time. So the question is, why do we have such fast failover? So typically in Community MySQL, recovery of a MySQL database can take a long time if you had long-running transactions that were aborted. Aura storage recovers near instantly. This is because of the unique distributed storage architecture that we have. So there's no checkpoint, and this architecture allows you to recover a database in parallel and out of order. So this is compared to the single-threaded nature of Community MySQL databases. So if you're interested in learning further, we also published a paper at Sigmod, and we lay out the details about the architecture design and explain the advantages of how we do better over traditional MySQL databases. So please take a look. But I also did want to cover about the RDS and Aura control plane. So the control plane does the automatic provisioning of instances. So storage volumes, so we automatic provision instances and storage volumes, but in addition to that, we also do monitoring and automatic recovery tasks as well. So as of today, customers run over 1 million instances across both Aura and RDS MySQL. This is across all our regions throughout the world. So security, availability, and durability are really our top priorities. So even if a small percentage of our instances have issues, this is still a large number to our customers. And we have various different health and security monitoring that provides automatic remediation. And given the hundreds of thousands of customers that Aura has today, this also helps us learn and continuously improve to protect our customers, even for the most edge use cases. And this is how we provide 4 nines of availability on Aura today. So a great example about how we monitor our instances is around multi-AZ failover. So as I explained in previous slides, doing self-managed failover is not that easy. So in addition to monitoring heartbeat, we can also monitor to see if the MySQL database engine is still up and running. So this is even helpful for things like network glitches, So we can see if the database is still available and determine whether failover is still the right recovery path. And we've also expanded our features beyond just plain MySQL, but also included things like BlueGreen Deployments, serverless options, as well as global database that Aditya will talk further in a moment. So let's talk a little bit about the open source contributions. So today, 5 out of the 7 RDS engines are open source or open source compatible. So these are RDS MySQL, MariaDB, Postgres, Aurora MySQL, and Aurora Postgres as well. So our customers rely on the security and long-term stability of these open source databases. So collaboration with the upstream open source community is critical to us to how we build and operate database services. So we collaborate with the upstream communities for both MySQL and MariaDB, as well as the broader ecosystem as well. So these include projects like Percona Extra Backup, HammerDB, as well as RocksDB. And our most recent open source innovations for MySQL include things like Advanced JDBC Wrapper that we talked about, which enables faster failover time, as well as the audit plugin for RDS MySQL. So our customers are in a wide variety of industries today. And really, our bread and butter industries are things like gaming and media and entertainment. And these are customers that typically have unpredictable spikes in demand, which really fits well with our database services. We can also make sure that we're still up and running and maintaining availability and durability during these peak hours as well. So these are customers like Riot Games that have high demand games, as well as Ticketmaster that have peak during certain hours. But I also did want to mention that many customers in highly regulated industries also leverage both RDS and Aurora MySQL. These are customers such in financial services industry like Capital One or Experian, but also in other industries like telecommunications or healthcare as well. So really the high performance, availability, and durability capabilities have helped these customers migrate off of expensive commercial databases and run their workloads both on RDS and Aurora MySQL. So with that, let me hand it over to Aditya that will talk further about a continuous innovation around both RDS and Aurora MySQL.
Thank you, Eugene. All right, just a quick introduction. My name is Aditya Samant. I'm a Senior Database Specialist Solutions Architect, and I specialize in RDS and Aurora platforms. So when you look at this slide, what you're going to notice is the pace of innovation. We initially launched RDS MySQL and Aurora MySQL, but our customers want us to continue the innovation, not just stop there. So what you're going to see here is that throughout the years, we continue to innovate at a very, very fast clip. And these innovations come to you as features and functionalities. Now, some of these features are incremental, and some of these features are generational leaps, like the Serverless V2 or global databases. So what we're going to do is we're going to spend next several minutes just talking about some of these innovations that are helping our customers. Now, let's start by talking about Serverless V2. Now, we all know that traditionally, vertical scaling is fairly hard to do in relational databases, right? And our MySQL customers told us that they are having this challenge when they want to scale up. And there are a couple of ways how you can scale up, and this applies to most relational databases. One thing that you can do is you can pre-provision all the scale that you need. The problem is that whether you use that scale or not, you are basically paying for it. Another thing you can do is you can scale up just before that peak. So if you know when that peak is going to hit, you can scale right before that. But that requires an outage. So none of these are great options. To help our customers, we innovated and delivered Aurora Serverless V2. So when you use Aurora Serverless V2, you are basically not having to even think about instance types and instance sizes, what you do with Aurora Provision or RDS Provision. You essentially think in terms of ACUs or Aurora capacity units. And what you do is you tell us what is the lower bound of Aurora capacity units you want, and what is the upper bound of Aurora capacity unit you want, and we take care of the rest. As the workload comes up, as the workload ramps up, the ACUs ramp up along with the workload, and as the workload goes down, the ACUs go down. And this ramp up of the workload and the ACUs is, that happens in a fraction of a second. So the scale up is happening instantly, it is fine-grained, and it happens in place. So there's no outage here, which means that you get the performance that you need when you need it, and when you don't need the performance, the ACUs go down, and then you don't pay for it, right? So the best of both worlds. So essentially, you're getting the cost savings and worry-free capacity management. Our customers love it. In fact, Aurora Serverless V2 is the fastest growing feature of Aurora. Its adoption is phenomenal. Now, our MySQL customers who have multi-region scale, right? The customers who have stacks that are deployed across multiple regions were struggling with multi-region scale, and they wanted us to deliver a global database capability. So we innovated in this area and delivered global databases. Now, if you're a MySQL customer, before global databases, you could do something like take a replica or take a backup, create a replica in a secondary region, take your bin logs, and create basically replication from one region to another region. This is absolutely possible, and our customers were able to do that before. The problem with that is the replication lag can become unmaintainable, right? Especially when you go across regions, and especially as you start adding more and more regions to it. So to solve this problem, we came up with our global database, which essentially does replication on a physical layer, right? So we take that storage layer that Eugene talked about, and we basically stretch it across multiple regions. Now, the use cases that it applies, the global database applies to, are twofold. One is cross-region disaster recovery, and the other use case is fast local reads. So in case of cross-region disaster recovery, let's say that in a rare scenario, there is a regional outage in your primary region. What you can do is you can go to one of the surviving secondary regions, click a button, or make an API call, and do a failover. When you do a failover, what we do is we promote that secondary cluster, the cluster in the secondary region, and if there are any other secondary region clusters, we are going to sync them up with this specific newly promoted cluster, right? And when the old region comes back up, we will add that cluster back into the global database topology. So your topology doesn't break, and your applications continue to work. So that's the global database failure use case. Now, we also have our customers who want to do things like follow the sun model. So that use case is supported using global database switchovers. So essentially what you do is you go to one of the secondary regions and you say, I want to promote this secondary region. You push a button, and then we promote that secondary region, we flip the replication, and global topology stays intact, right? So you can do failover and switchover, and this is fully managed. Now, another thing that global database also supports, of course, other than the local fast reads in the secondary regions, is write forwarding. So if you have use cases where your secondary region applications that live in the secondary region do mostly reads, but every once in a while they also have to do writes. So what we do is you can use the same read-only endpoints and actually send writes to them, and these writes will get forwarded over to the primary region, right? So essentially, multiple cross-region use cases are unlocked using global databases. I just wanted to also mention that global database replication is asynchronous, and it is done on the storage layer. So we're not using bin logs here. The replication is done on the storage layer, and because the replication is done on the storage layer, you basically get a massive read scale across 6 regions and roughly 90 read replicas. Now, another thing that our customers really asked us to deliver was fast database copies, right? So whenever you need to do copies of your database, what you can do, if you're a MySQL customer, again, you can take a backup, maybe do a logical backup, maybe use a snapshot and restore that snapshot. Perhaps you use bin logs to sync up those snapshots and get them caught up. Now, the problem with this is the time it takes to create this copy scales with the size of the database. The larger the database, the longer it's going to take for you to restore this or create this copy. So to solve this problem, we innovated and delivered Aurora Fast Cloning. So as the name suggests, Aurora Fast Cloning is basically instant, right? So when you use fast cloning, what we do is we're not even creating a new storage. We're not even creating a new replica or anything. What we do is we take the existing storage and we attach a new compute to that, right? And this is possible because we have this massively distributed storage subsystem under the covers. So essentially what happens is because there is no page movement happening, right? So when you create a clone, what we do is we use a copy on write algorithm. So essentially if there is no change in the primary or in the clone, no pages are moving at all. So you just attach a new compute and now you have a clone. So you have a fast clone, you can use it for various use cases like running point-in-time reporting, snapshot analysis, maybe you want to test your upgrade. There are lots of use cases there. And another advantage is because you're not creating a new copy of the storage, you're not paying twice for the storage. When you start making changes to the pages either on the primary or on the secondary, that's when the pages start to diverge and that's when you start paying for the clone storage. Another thing that you can do with fast clones is you can actually run fast clones in a headless cluster mode, which means that you can choose not to even attach a compute at all. You just create a point-in-time copy, which is a clone. Now, Aurora machine learning is quite the buzzword right now, but our customers have been asking for machine learning integration for a while, and we have delivered machine learning integration roughly 3 years ago with Aurora MySQL. So what our customers asked is they wanted to enrich their relational database data without actually having to learn machine learning models. And they wanted to use just SQL queries. So what we delivered with Aurora machine learning integration is that you get the ability to take advantage of our machine learning capabilities, such as SageMaker and Comprehend, and you can just use those endpoints directly from Aurora. And you can do that by just running regular SQL queries. So how does that work? Here's a quick overview of what a machine learning application with databases looks like. That it's a multi-step process. You have to select and train a model, you have to write the application, you have to format the data, you have to feed the data, you have to process the data, right? So what happens with machine learning integration is that this six-step process becomes a three-step process because all you gotta do is just select and configure the model and run simple SQL queries, enrich your data, and take advantage of the machine learning capabilities. Now, Eugene talked about the distributed storage and how fantastic it is, right? The distributed storage has always been pretty flexible. It was built ground up for flexible usage. The storage grows and shrinks as your usage grow and shrink, and so does the IOPS, right? Which is great for our customers and exactly what they wanted. But the other thing that our customers also wanted is a predictability in pricing. When you have a flexible storage that can grow and shrink and IOPS that can grow and shrink, that also means that the cost is variable. Now, some of our customers really wanted predictable cost. And to help these customers, we delivered Aurora IO Optimized. So what happens with Aurora IO Optimized is when you enable this feature, which is, by the way, you can do at any time, and it does not require any downtime. When you optimize or enable Aurora IO Optimized, essentially your IO cost or IOPS cost becomes zero, right? So once your IOPS becomes zero, it doesn't matter how much IOPS you're using. Since there's no cost, your cost becomes predictable because you're only paying for compute and storage. Now the question is, if the IOPS becomes zero, where does the other cost go? So essentially what we do is when we make the IOPS cost zero, we are upcharging for the compute and the storage. To kind of demonstrate that, I'm just going to talk through a simple example. So let's just assume that your Aurora costs are $100. $65 you pay for compute, $5 go to storage, and the rest go to IOPS. Right now, this is somewhat of a typical distribution. Sometimes compute is higher, sometimes IOPS are higher. But essentially you kind of get the idea, right? So what's going to happen is as soon as you flip the IO optimized switch on, your IOPS costs are going to go away. And this $100 suddenly become roughly $96 to $97, right? You get upcharged on the IOP compute and the storage, but the cost immediately go down. Now, if you think about it, the more IO you use, the more you save, right? So if you're using 30%, you save a little bit. If you're using 40%, you save even more, because no matter how many IOPS you use, you don't get charged. So that gives you the the price predictability. Now, if you are a really heavy user of IO, it's not only going to give you predictability in price, but it's also going to be a cost-saving measure. Now, additionally, when you enable IO optimize, even though it is just a billing measure, we have the ability to do certain things in the back end because we are no longer charging you. And as a side effect, you get better IO throughput and lower IO latency. So it's kind of a win-win scenario, especially if you're a high IO user. You pay less and it works faster. All right, so we have been talking mostly about Aurora. I'm going to start talking about Amazon RDS MySQL and Aurora MySQL. And this is one of those features that applies to both of the platforms, which is RDS BlueGreen Deployments. Now, our customers told us that when they do things like upgrades and patches and like schema changes, that requires outage. And they wanted some way to avoid or minimize the downtime or the outage. Now, if you're a MySQL user, you could potentially do something like that, which is the BlueGreen deployment yourself. You could take a snapshot, restore it, use a bin log, create a replica, and then make all your changes to that replica. And when you're ready, you can do a switchover. Now, while this sounds pretty simple, it's quite a bit of heavy lifting. If you have ever tried to do that, you would agree with me. Now, in addition, you will also have to switch the endpoints, so this is quite a bit of work. So what we have done with RDS BlueGreen deployments is we do all of this work for you. We do all of this heavy lifting for you. All you have to do is tell us that you want a BlueGreen deployment, click a few buttons, and we create a green replica. So you have green, blue that is your primary, and then you have a green replica. You can make all the changes to that green, and when you're ready, you click a button, and we flip the endpoints for you, we change the names, and then we rename the old instance, and the new instance become available, so all of your changes are available in that new instance, and applications don't have to make any change, right? Now, in addition to this, we also added some guardrails, like zero data loss, for example. So when you do this BlueGreen deployments, or when you enable the BlueGreen deployments, when you push the button, you can tell us how long you want to wait. Do you want to wait for 5 seconds, 20 seconds, 5 minutes? And if it takes more than that, then we completely stop that and roll back. And essentially, there's you go back to normal. So if you have certain time limits within which this has to happen, you can make that happen. Additionally, there's no data loss because we are going to pause all the writes when you push the switchover button too. So lots of guardrails there. All right, so if you're a relational database customer, you always want more performance. And our customers told that they wanted more performance for their writes and reads. So one of the things that we did with RDS MySQL is we delivered this feature called Optimized Writes. Now, if you're a longtime MySQL user, you would know that there is this structure in MySQL called double write buffers. So essentially what happens is when you try to flush your buffer pool, that data first goes to the double write buffer, and then eventually it makes it to the DB file. Now, this is primarily done to kind of safeguard against any sort of hardware failures. Now, hardware has come a long way. Now, it's not completely perfect, but it's significantly better from the early days of MySQL. So what we do to kind of reduce this write amplification is when you enable optimized writes, we completely bypass double write buffer. Now, while we're bypassing double write buffer, we want to make sure that the reliability is still there, right? So to make sure, what we do is we use atomic writes feature of the NVMe drives. So when you use the atomic writes feature, the NVMe drives guarantee that even if there is a data power outage or something, that data is not going to be lost. So because we kind of bypass, as the name suggests, double writes, well, it's not exactly double, but there is write amplification there. So we're skipping that, and that actually gives you, improved write performance. And this feature is available in RDS MySQL 8.0.30 and above. And here's a quick benchmark of the write performance. So we did a benchmark on R6i 16x large instances. And you can see that the orange bar is with double write buffer on, and the gray bar is with the double write buffer off. And you can see that there is significant improvements, as much as 2x in the transactions. So continuing the performance improvement theme, we also delivered a optimize reads feature for RDS MySQL. So what MySQL does is when you're running these complex queries that uses CTEs, or if you're doing group by or order by, it's going to use temporary tables. Now, when you use temporary tables, that data first goes to memory, and then eventually it spills over to a disk. So traditionally, this disk was an EBS store. When you use optimized reads, what we do is instead of using EBS store, we are going to flush this data to a local NVMe disk, right? And because of this, when you enable optimized reads, we have seen that the queries can be as fast as 2x faster. All right, so these are some of the improvements that we have done over the years. Let's take a look at what's new in Aurora MySQL. So first, earlier in November, we launched this feature called Zero ETL integration. I'm sure everybody has heard about it. So several of our customers told us that they have these complex ETL pipelines when they're trying to move data from Aurora to Redshift. So to kind of reduce that heavy lifting and complex pipelines, we launched the Zero ETL feature. So what Zero ETL integration does is you can essentially just enable this, and we are going to take your Aurora MySQL data, and we are going to move it to Redshift. And when you use Zero ETL, when you're writing the data to Aurora MySQL, it becomes available in Redshift within seconds. So you're basically getting very low latency, almost real time, this replication pipeline that you can use for your analytics workloads. Now, our benchmarks have shown that Zero ETL pipeline can process over 1 million transactions per minute. So this is pretty well performing, and you should be able to use it for not just one Aurora instance, but you can use it with multiple Aurora instances that can go to move your data to Redshift. Earlier this year, we also launched enhanced bin logs. So we all love bin logs. Bin logs unlock a lot of replication capabilities, and there's a lot of ecosystem around it. But we also know that when you use bin logs, it adds additional latency to your writes. So our customers wanted to use bin logs, but they also wanted to reduce the latency. And sometimes these write latencies are amplified on Aurora. So what we did is we basically delivered this enhanced bin log feature, which reduces the write latencies compared to community bin logs. And it also improves the recovery performance dramatically when you compare to enabling the bin log is enabled on Community Edition MySQL. Additionally, on Aurora MySQL 3.04.0, you also have the local write forwarding feature now. So we talked about write forwarding feature on global databases. So the same write forwarding feature can now also be used in the local, within the regional read replicas as well. So if you have use cases where you want to use the read replicas not only for reading, but if you do occasional writes, you can do that, and those writes will get forwarded to the writer. Earlier this year, MySQL also talked about a new versioning scheme, right? So there is now an LTS, or long-term support, and there is going to be a innovation release. So we are committed to supporting the at least the LTS release for Aurora, and I'm going to talk about the innovation release in a minute too. So we are going to provide continuous support for future versions of MySQL for Aurora MySQL. In terms of RDS MySQL, what's new is with RDS MySQL 8.0.35, we have done some internal optimizations, and what we have seen is in our benchmarks, we have seen up to 3x performance improvements for write throughput. So if you have workloads that require additional write throughput, consider upgrading to RDS MySQL 8.0.35. Now, additionally, just a month ago, I want to say a couple of weeks ago, we also released support for group replication plugin. So if you have use cases where you need continuous availability, and if you want to be able to do things like an active-active deployment where you can write to any of the RDS MySQL nodes, then you can use the group replication plugin for these active-active configurations. We have released a blog about it, and it talks about the group replication in detail. Eugene talked about multi-AZDB clusters with readable standbys. Multi-AZDB clusters now also support rolling upgrades, and they also support RDS proxy. So if you had use cases where you wanted to use RDS proxy for multi-AZDB clusters, now you can do that. We talked about innovation release for MySQL. If you want to try out innovation releases, they will be available in the RDS preview environment. So if you wanted to test out features, see what's new in these innovation releases, you can use it in the preview environments. And of course, just like Aurora MySQL, we are committed to providing future community MySQL version support for RDS MySQL as well. Now, we all love newer versions and features and functionalities. Every time a new version comes out, we probably want to go out and try those features out. But at the same time, there are customers who are using legacy code, and they're still running on older versions of MySQL. And they need more time before they can move on to the next version of MySQL. So these customers asked us for a mechanism instead of asking for continuous extensions. And we made this mechanism available using Amazon RDS Extended Support. So this RDS Extended Support is available for both RDS MySQL and Aurora MySQL, and also Postgres. But essentially, when you enable extended support, what we do is we are going to provide you critical security patches and critical bug fixes while you're on this support. And you get 3 years of additional support beyond the standard life cycle of the product. If you're using Amazon Aurora MySQL, then you are going to get this 1 year of extended support for free. And we have some customers that are already using this feature and loving it, and we have some kind words here from Tokyo Marine and Nichido Fire Insurance Company. All right, so I'm going to hand over to Eugene, and he's going to talk about a couple of use cases from our customers who are using Aurora and RDS MySQL.
So let's cover a couple customer use cases. So let's start with an Aurora MySQL use case. So Intuit's a great example, which is a leading financial management software provider for individuals, small businesses, and also accounting professionals. So if you're based in the US, you're probably pretty familiar with them, with their TurboTax service as a way to file taxes online easily. So when their on-prem environment running TurboTax application was due, they're looking for a robust database that can meet the performance and availability requirements. So TurboTax is primarily used during the tax season. So it has highly fluctuating demand that requires also high availability and durability. So TurboTax can't stop during the top tax season. So they needed a commercial-grade database system that can also help them reduce costs, but also support peak load demand. Beyond just direct cost savings, by moving to Aurora, this has helped them, especially with their DBAs, to spend more than 80% less time on maintenance tasks. And features such as automatic growth of our storage capabilities, which can go up to 128 terabytes, security features like encryption at rest and encryption at transit had really reduced the time that the DBAs are spent on managing databases. They also use DMS, or Database Migration Service, as a way to move from on-prem environment and move 33 applications and 26 services that are running on AWS. So another example is Freshworks. So Freshworks is a software as a service company that provides purpose-built software for IT professionals, customer support, sales, and marketing. So they're a classical example that started from a startup and grew to an enterprise in a very short time frame. So they have over 56,000 customers that are operating globally. So they're using a third-party cloud application software to run their MySQL databases, but they needed a solution that can help them scale out as they grow their business on a global basis. They also needed the right availability and durability characteristics to make sure that their applications were up and running. So they selected RDS MySQL, which made them easy to set up, operate, and scale MySQL deployments. And by migrating to RDS, Freshworks can now handle over 1 million requests per minute. And this is especially helpful during their peak hours, where the web requests skyrocket. And they continue to increase throughput every year, which they now can handle over 1.69 billion requests per week. So to achieve high availability, they've actually leveraged multi-AZ deployments that they're using today. Okay. So key takeaways and wrap up. So AWS is the home to the largest managed MySQL fleet. So we talked about that both RDS and Aurora MySQL have over 1 million instances that we're managing today. We have a rich history of innovating in the managed MySQL space, and we continue to innovate quickly with various features that we introduced today with things like global databases as well as Aura Serverless. Security, availability, and durability are really our most important tenets to make sure that our customers' mission-critical workloads are up and running. And we strive to continue to be the best place to run and scale your MySQL workloads. So that's all for today, and thank you for joining.